Hey everyone, I am very proud of you for watching this and studying. So here is the review answers. Remember, when you are classifying a polynomial by degree, you have to look at the highest exponents. I'm going to do 2 and 3 and then re-talk about 1. 3, I see that my highest exponent is 3. So the degree is 3, but we're classifying using vocabulary when we have it. So for 3, it's cubic. 2, the highest exponent is 2, it is quadratic. Highest exponent 1 is linear, and if there's no variables, it is constant. It's a little bit of a different situation when you have a term that has more than one variable. If there's more than one variable, then you need to add the exponent to get the number of degrees. When you're classifying by the number of terms, remember mono means 1, bi means 2, tri means 3, poly means many. So if you can say something more specific, please do, but if it's more than 3, you can just say polynomial. You also need to know for this standard how to put something in standard form. Adding and subtracting polynomials are very easy if you remember your addition and subtraction rules and you remember what like terms are. So be very careful when it's addition. All you need to do is find your like terms and add them together and put the variables in descending order based on the degree. So here were like terms, my x's were like terms, and then the constant. Here, to the 5th is one like term, so -4 plus 5. Be very careful to not drop negatives. So you just line them up. Feel free to do it vertically if you want. You could have written this under here, and to the 3rd under here, and then the constant behind and added it that way. With subtraction, do not forget to adding the opposite. I did this one vertically, so it was minus, and then I changed it to adding, and then I changed all of these to their opposite signs. So positive became negative, and negative became positive, and I lined it up that way. If you wanted to change it right in the problem, you could. That's subtraction to addition, and then all of them to their opposites. So this one might have been a little tricky because there is two like terms in the same polynomial, so I combined them, and then I did the same as I did with number 6. I changed subtraction to addition, and then each to its opposite. So if it was positive, I changed it to negative. If it was negative, I changed it to positive. Positive to negative. All right, if you're multiplying, it doesn't matter if the binomial that you're multiplying is behind it, like in 8 and 9, or in front of it, like 10. Be very, very careful to not drop negatives. Negative times a positive is a negative. 1 times 4 is 4, and then x times x squared. Remember, if you're multiplying powers with the same base, you add the exponents. Negative times a negative is a positive, 1 times 7 is 7, and x times x is x squared. So remember, you are doing the signs, the numbers, and then the variables. So here, positive times a negative is a negative. 6 times 3 is 18. X to the 3rd times x squared is x to the 5th. You add the exponents. Alright, and the same with this one, there's just more of them. And if it's not in standard form when you finish, please put it in standard form by descending degrees. Binomials, when you're multiplying binomials, feel free to use the distributive property or the FOIL method, as long as you remember that each term, if one binomial, needs to be multiplied by each term of the second binomial. So first, outer, inner, last. And then combine your middle terms. So first, outer, inner, last. And then combine your middle terms. Again, be very, very careful to not drop negatives. Alright, 14 was a lot because you first had to do the distributive property here, and then you needed to do the distributive property here, remembering that this is negative, so you're multiplying out a -4, and then the distributive property here, remembering this is -3, not just 3, and then you needed to combine like terms. So order of operations, we had to fix up this multiplication before we combined our like terms. And same with this one. This 14 had addition subtraction in it. This is just straight multiplication. And it's like the FOIL method, except there are 3 terms. So there's a trinomial times a binomial. But each term in the trinomial has to be multiplied by each term in the binomial. And then when you're finished, combine like terms. Alright, 16 is similar to 14. You needed to remember that multiplication comes before subtraction. So 6x times 3x is 18x squared. First outer is 12x, inner is 12x, and last is 8. We combine our like terms, and then you needed to subtract all of this from that 4x squared. So I needed to change everything to adding its opposite. So 4x squared plus a negative 18x squared, that is where I got my negative 14x squared. And then 4x squared plus, this is the only like term with this. And then so we just needed to rewrite the rest of these. 17. Some of you still are not remembering that x minus 6 squared means x minus 6 times x minus 6. You could certainly simplify this using the FOIL method, but I'm hoping you remembered the shortcut where you square the first, you square the last, and then you multiply these 2 terms and double them. This is like your outer and your inner. So without even writing this out, I knew x squared for my first. Uh-oh, that's 12. That is not supposed to be 12. That is supposed to be 36. Oops. So 36 for my last, and then I multiply these 2 together and then double it. So here I have 2x squared squared to get 4x to the 4th, 5 squared to get 25, and then I needed to multiply 5 times 2x squared to get 10x squared, and then I needed to double it. And it looks like this is addition, so that's why this is addition. For 19, it is that shortcut where it is the sum and difference of 2 terms. So my first terms were the same, my last terms were the same, so that means the outer and the inner would cancel out, so I just had to square my first term, square my last term, and it's a difference. This one is not a shortcut because this is a 2b where this is just a b. So I just had to do the first, outer, inner, last, and then combine my middle terms. 21, not very difficult at all. I needed to find the area of this whole shape by finding the area of this, the area of the little one. Probably the most difficult part of this whole problem is some of you did not know how to combine this. 1/9 x squared plus x squared. X squared, that's a 1, and if you have to combine your fractions, that's like 9/9. 9/9 is the same as 1, so 9/9 plus 1/9 is 10/9.